Hey everyone, I guess we are live.
Yep,
Uh,
we are.
People
We are.
are joining in. I'll just let everyone get settled for a couple of seconds. Hello from the Dominican Republic. Hello, Frederick.
Let us
Hello,
know
Omar.
where you are from, where you guys are joining from. Let us know in the chat. We would love to see participation in the chat from the get go. Hello everyone. Hello, hello. Thanks for joining. Thanks for joining.
Thank you. Montreal,
Montreal.
Canada. Welcome.
Hello from
Okay,
India,
I
by the way.
guess I guess everyone is settling in.
Yeah.
So, hey everyone, I am Ritik, and this is Arthro from PyImageSearch.com. Hi, Arthro. And yeah, this time we are back with another topic on NLP. And this time we are going to talk about neural machine translation. So if you are joining us in the chat, then a few things to like break the ice before we get started. First of all, if you have any queries, if you have any questions that you would like to ask us, if you want to discuss something that with us, then feel free to post your queries, your comments in the comment section, in the chat section. I This is being broadcasted to YouTube, LinkedIn, and to Facebook.
And that's
So
the
if you
first time we are doing this, by the way.
yes,
Just letting you all know that's the first time. So if there are a lot of comments coming in, we would love that. So from Facebook, from YouTube, LinkedIn, just pour in all the comments. We love interactions. We'll be happy to help you out with the questions and answers.
absolutely, absolutely. And like if you do not see the chat option, you can always head over to YouTube. You'll find the YouTube in the description, YouTube link in the description, and you can post your queries in the chat. If you're joining us after the stream, this is not for you guys, but if you're joining us after the stream, then you can post your comments in the comment section. And David, thank you. Good day. Good to see you. Unfortunately, Dave is not joining us today, but he promised that he'll be back next time. So, hello,
David,
everyone.
I see you. I was just missing. Where is David? Where is David's comment?
Right.
It just makes my day so much better.
Exactly. And guys, if you have two things to keep in mind. If you have your queries, if you have your questions, post them in the chat, post them in the comment box. We will be looking at the chat, but we will be, providing particular intervals throughout the live stream where we will be going through your chat and your queries. One of us will be keeping an eye on the chat. So do not worry if it is not addressed right at that moment. We will provide particular intervals throughout the live session for those queries to get resolved. And secondly, if you are a regular, you would know that there is something that we are going to offer you for joining today, as a thank you, as an appreciation, as just for the love that you show in this community. So stay tuned till the end, and you'll find that those offers, those surprises. And so here are the topics that we will be covering in this tutorial. It will mostly be focused around the concept of neural machine translation and how it can be expressed in mathematical terms. We also talk about what will follow in the upcoming tutorials that are yet to be published. And this is one such tutorial. This is a sneak peek from one such tutorial which is not yet published. So you guys are lucky, and this is going to be the first time this is publicized. So moving on, uh, let's let's forget about deep learning for a moment. Let's imagine a point of time. I guess this has happened to all of us. Imagine you find an article that is really interesting on the internet, and as luck might have it, it is not in your mother tongue or the language that you're comfortable conversing in or the language that you know. You chuckle to yourself, but then you find a little small option on the top of the page to translate the entire text. and you thank the technology gods, read the article, and move on with your day. But being the curious person that you are, something clicks. The web page may have more than 2,500 words or even more than that, yet the translation happened in a matter of seconds. Unless there's a super fast person smashing keyboard somewhere inside your browser, this must have been done by an algorithm. And there is your point. How is this algorithm so accurate? What makes such an algorithm perform robustly in between any languages in the world? And before we move on to that question, that particular curiosity that we want to address, this section is for those of you who are on the fence about joining PyImageSearch University. So this was the offering or the surprise that I was talking about. David knows all about our surprises, uh, and if you have been putting it off for quite some time now, here are some things to consider. Um, and it's based on the stream of testimonials that we receive from ex-students or students who have passed out of Pioneer Search University. And firstly, there are two things to consider, right? If you notice on the screen, there are two QR codes. Now, the QR code on the left is your regular PyImageSearch University, and the QR code on the right is something new. So we are launching a brand new course called Computer Vision with Arduino, and it's so new that the sales page isn't up yet. So if you scan that option on the right, it will take you right to the checkout page where you get PyImageSearch University plus this brand new course of computer vision with Arduino that allows you to do face detection, gesture detection, and really cool computer vision applications through through Arduino. So that is off for 25% exclusively for you guys today. And the link on the right is PyImageSearch University, which is off for 21% for everyone. Someone mentioned phone just died as I was scanning them. Unfortunately, I'm sorry. I will post the link in the description in the chat box. Do not worry about that. And Arthur, you have something to say over here?
Yeah, just while while you were saying that we had a stream of testimonials, I would want to quickly jump on that and say that we indeed have a YouTube channel which has a playlist of all the testimonials that we have we have received, as well as some testimonials are being processed for people to see. And these testimonials are something which personally make me strive for more in PyImageSearch. So it is very overwhelming to know that somebody has gotten a job, or maybe cracked a research paper, or made their first publication at a well-known conference with the help of our blog posts. And it feels unreal, if I speak the truth. So having said that, it also means that the testimonials backed up by our alumni kind of makes sense for you all to jump right in into our course, because this is not just us speaking to you. This is a whole army of PyMetric students backing right up and saying, go for it, it's worth your time, it's worth the money. And yeah, and it also says, like in the slide we have also noted that it's like 66 cents per day. So if you think about it, the investment that you're going to make today is going to have a lot of returns.
And it's
So
less than a cup
yeah,
of coffee.
yeah, absolutely. So that is always there. It's less than a cup of coffee. Don't think it twice. Um, Go scan, or maybe click on the link that Ritvik has shared in YouTube chat. I think it's also, yeah, it's also shared in the Facebook as well as LinkedIn chats. So go ahead, check it out. And if you're still on the fence, not quite sure, take it. We have a 30-day guarantee, 30-day money back guarantee. If it does not work for you, it's okay, we understand that. And you have your money back at in the in 30 days. So I think that's that's about it from my end.
Right. And just on that note, yeah, I'm seeing a comment from someone who says, is PyImageSearch University going to add topics or courses around transformer models and vision transformers? Yes, we
I'm
are
so
both
happy.
vision transformer fans.
I'm so
And
happy that this question has arisen.
around BERT and GPT-3. So just around that note, uh, PyImageSearch University is the only place where you will get consistently cutting edge research topics and blog posts and tutorials around that. And it's going to be code that works, that you can just take from us, put in your system or in your collab notebook, or in your office space, and just make it work. Tweak the parameters to your heart's content and play around with them. So that is always going to be there. The link on the left is PyImageSearch University. The link on the right is PyImageSearch University with the brand new course, Computer Vision with Arduino. And the link on the right is discounted. It is usually 240 a year, but it's discounted 21%, and it will give you the full access plan. And then there is the computer vision with Arduino along with PyImageSearch University, right? So that is there. Um, you can always scan those links, take a screenshot, or you know uh, access the links from the chat box. And now moving on. So back to our original question: how did the translation in between two languages through Google Translate or through any services that you use happen so fast? So this is a special area of natural language processing, and it's called neural machine translation, which is defined. Now we have to talk about the definition a little bit. So it is defined as the act of translation with the help of an artificial neural network. And that might sound like a mouthful. Now I just gave you a formal definition. Now I'm talking about probabilistic overview, and you're probably thinking, okay, this is enough. I cannot take this anymore. Too much math. I need to go give my head some rest. So I feel you. I understand where you're coming from, but just stick with me, because this next part, the math behind NMT, is going to make your foundation so rock solid that you will never have to go and find another definition or another, how should I say, a math equation to understand neural machine translation. So before we go any further, let us just take a little moment to refresh our memory of probability. So we have all probably seen this equation, Py of x, right? And it refers to the probability of the event y occurring given x has already occurred. This is what is called as conditional probability, and we all might have come across this, even though some of us might not remember it exactly, but we all know about this. Now imagine y and x on the screen being replaced by f and e, where f is a sequence of French words and e is a sequence of English words. Now if we apply the same definition of conditional probability here, it will mean that Pf of E in place of Py of x is the probability of a sequence of words in French occurring given that there is a sequence of words in English E that has already occurred. Now, I just want you to forget about probability, forget about everything, and think about this for a moment. What we are essentially doing is transforming the problem statement of translation into something that can be understood and operated on by neural networks. How are we doing that? We are telling that given that there is a sentence that already exists in English, what is the probability that there will be a set of words or a sentence in French? Now, what this does is that this takes translation as a concrete problem, as something that you'll always have a concrete French sentence for a concrete English sentence, and it throws it out of the window. It says that given that there is an English sentence, there is going to be a range of French sentences. So French sentence one, French sentence two, blah, 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 French sentence N. And what there is going to be after that is that there's going to be a probability distribution, or there's going to be a probability of which French sentence corresponds to that English sentence. Now, that is a much more meaningful definition of translation for neural networks. Now, if you have been with us for some time, or if you have known PyImageSearch and deep learning, you would know that deep learning loves to operate on condition, on probability. If you give a neural network, the output of a neural network will eventually be a probability distribution, and you would select the maximum out of it. And that is what is done here. This actually means that the task of translation from English to French is to maximize the probability P(f) of e. So the neural network's task is to learn the conditional distribution. So the red line that you see on your screen, I'm sorry, I cannot pause the GIF, but the red line that you see on the screen is actually an estimated distribution of the probability. And the neural network's task is to find where that conditional distribution is the highest. And when a source sentence is given in English, its task is to search for an appropriate target sentence in French by maximizing this conditional probability. And I want all of you to take this in and understand it. And if you need more time to do that, I'm happy to go back. But please tell me if this makes sense, holistically.
It's a beautiful analogy, Ritvik. The one that you're showing us right now, the conditional probability, and coming from conditional probability, how you would think of the machine translation task to be a conditional probability task, like molding one problem statement into the other so that a neural network can operate on it. That is a beautiful analogy. And sorry to interrupt while you were already at it. I saw a bunch of comments inquiring whether uh, our recording, like whether we are recording this. We are absolutely going to record this. Uh, if you are if you are working right now and cannot join the stream, just after the stream, I guess it takes 1 hour for YouTube to process the entire video, and it will be available at our channel. So don't forget to
Just,
hit the like and subscribe button so that you get notified right after we conclude our stream. So yeah,
and
Ritvik,
just
you were
to just to be on that, have everyone on the same page, the recording will be available, but the offers or the discount codes that you see on the chat or on the screen through the QR codes will expire, because they are meant for the people who are joining the live stream. So if you do stick to the end, or if you have decided to purchase it, that will allow you to get the discount codes, rather than if you come back tomorrow or next week, then the QR codes or the discount coupons will be expired. And you can actually check this out, but I hope that you do not, because then it will only be a loss for you. So with that, that was a lot
And
of
Ritvik,
math.
we already
Yes.
have a fan of our graphics, so we might just be clear with what we use while we do our graphics, just letting them know. So Frederick, thanks for letting us know that you like the graphic. And Ritvik, you were saying.
Yes, and regarding the graphic, the animations that we use in our blog post, in our course materials, in our video lectures are generated through Manim, which is a programmatic library in Python to generate, beautiful visualizations like these. It is used by the YouTuber 3Blue1Brown. So yeah, and thank you, Frederick. And moving on, um, so we understood how that makes sense, how translation can be defined as maximizing the probability distribution, given that there is a source sentence in English E, that there will be a maximum probability of a French sentence or a sequence of words occurring in, which is called F. Now, neural machine translation is the process of leveraging an artificial neural network to maximize this conditional probability. And I will ask Orithro, my colleague, to explain us how exactly that architecture or that artificial neural network works, so that we can, derive this probability and find the optimal or the accurate translation.
Right. So here I am. Thanks for the question. If you all have been through any of our videos, like PyImageSearch videos, be it live stream, be it from PyImageSearch University, you might know that we are a code first kind of a company. We always want to push our students to coding first, understanding the concepts right when you're coding, and hence you can also utilize your set of skills which you use for code, and you also understand the concepts. But I have to let you all know that the whole PyImageSearch team sat down on a call and thinking about how to structure neural machine translation, because it is one of the areas that need a little bit of theory before going into code. So this stream, we don't have any code per se to showcase. We will just try to imbibe the intuition behind neural machine translation, the math behind it, the probability or the conditional probability that beautifully was explained by Ritvik. And my goal is for all of you to go back in time, understand what we covered, and then go forward. So the first the first intuition that Ritvik tried building and was absolutely spot on is about the conditional probability, like molding from one problem statement into another. And you will find this beautiful, transformation from one problem statement to another in a lot of deep learning concepts. One of them is NERF. I'm not going to say how it does it, why it does it. Check out our blog posts on NERF. But in neural machine translation, if you think about it, it's you just could um, translate maybe a word to a word. Say you have an English word, and that English word corresponds to a French word, and you can just translate a word to a word, but that won't make sense. Why doesn't it make sense? Because what we also know that the English sentence, that is the source sentence, has something called a context. Now the context cannot be absolutely translated into the French context. You need to reorder some words, you need to add in some accents to make sense of the emotion that is that has been evoked inside of the source sentence into the target sentence. Does that make sense? Now think about this. Now that it is not a absolute problem, we have to mold the problem statement for the neural network to understand it better. So for a neural network to understand it better, what authors have already done is that they have molded this problem statement into conditional probability. Now why conditional probability? The source sentence is something that we already have. So the source sentence is an event that has occurred, and the target sentence is something which we don't have. So that is something which will occur, right? And this makes intuitive sense right now, because something has occurred and something is going to occur. What is the probability of this event occurring when something has already occurred? Conditional probability. Now once you think about this beautiful analogy of conditional probability or the molding of the problem statement into conditional probability, it's just going to make sense from here on onwards. So the math behind NMT, I took a lot of time, uh, kind of in a hand wavy gesture about what conditional probability is. So let's get into the math behind NMT. So the first, I see Abhijit saying encoder-decoder is the distribution achieved by softmax, and a lot of questions coming in. I love the questions, but I'm going to hold off to the questions a little later, because all of the slides are going to answer them eventually. And if I have missed out something, please let me know. Please let us know. We are going to answer them. So the first thing that you are going to understand is that we have a pair of things to translate to and from. So there is something called a source sentence, and there is something called as a target sentence. So what we need is to encode this source sentence into a representation and then decode that representation into the target sentence. So this happens via two pairs of neural networks, one called the encoder and the other called the decoder. So most of the neural machine translation tasks happens with encoders and decoders. And if you all have seen our last live stream, we did a live stream on recurrent neural networks, and this will feel right at home. This architecture will feel right at home if you are well versed with recurrent neural networks. If you're not, don't fret. We have a blog post. We have a series of blog posts. Beg your pardon. We have a series of blog posts on recurrent neural networks, on long short-term memory networks, and how to model sequence of data. And why do we need sequence of data? Because we have sequence of data. So the source sentence is a sequence of tokens and the target sentence is a sequence of tokens. We need to model sequences. So the encoder here is an RNN, the decoder here is an RNN again. Now, disclaimer, when I say recurrent neural networks, it might not mean recurrent neural networks as in RNNs only. What I mean to say is it's a sequential model. You can use a GRU, maybe. You can use an LSTM, maybe. You can use an RNN. You can use a unidirectional LSTM, bidirectional LSTM. There are a lot of things to, uh, you know, get your hands dirty with. So, how do you look out for what recurrent neural network to get? Absolutely up to you. We don't get sponsored by any recurrent neural networks. So anything, go to TensorFlow, go to tf.keras, look out for the documentation, beautifully written. Check it out, use it. Go to our blog posts. We also have we are TensorFlow and Keras lovers, so we also have like all of these API documentations given properly. So coming back to recurrent neural networks, we have this encoder and the decoder. And now, why did I take so much time into explaining this slide is because right when we go into the math, we would come to and fro from that slide of math and directly attach that math into this visual. So before doing that, I need to explain what are the things that we are going to see. So start, are you paying attention, question mark, and end. This is the source sentence, which is in English. And this is the encoder. This is a series of recurrent nodes that encodes the entire sentence into a context vector. So people from PyImageSearch, you all already know we have covered a lot on auto encoders. This is not an auto encoder, but stick with me with the analogy. With auto encoders, what we had is we had an input and we encoded that input into a latent vector, and that latent vector was again decoded into an output, which was later computed the loss upon gradient backpropagation, all that. But what I'm trying to make you all understand is that this bottleneck, this context vector or this latent representation that has been encoded into, that is the input gets encoded into this, is what we need for decoding. Similarly, in an encoder-decoder, as shown here, we need to encode this entire input sequence into a context vector, which is then goes to the decoder and gets decoded, right? So this, take a look at this, feel like imbibe the visual so that it's easier for us to travel through the math. Right after that, we have our first equation. H of t is an output of a function which depends on x of t and h of t minus 1. So what are these symbols? T is the current time index, right? So t here means the current time index of h. X of t is the current time index of x, and ht minus 1 is just one previous one at the previous stage, not the current one back at it. So if you all remember the RNN sequence, this is the hidden state equation. So what this essentially does is h of t is the hidden state, or the current hidden state or depends on the current input, that is x of t, and the previous hidden state, that is ht minus 1. So going back to the visual, start is x of 0 or x of 1. That is the first input that goes into the RNN encoder. Due to the fact that we don't have anything coming inside of the first RNN state, let's assume that the first hidden state or the hidden state minus 1 is a sequence of zeros. We can take zeros, we can take ones, or any random number. And the start and the previous hidden state builds the current hidden state, that is h of 0 or h of 1, however you index it, right? So that is how you build the recurrence, and that is how you build the recurrent neural network. Now that you have all the input tokens getting into the RNN, you will have all hidden states coming out of the RNN as well. So going back to this, can you see the is it horizontal? Yeah, horizontal lines. I always confuse between horizontal and vertical. So horizontal lines coming out of the RNN nodes, these are the hidden states that comes out of every current input state. So start, if considered to be 1, this is h1, r is considered to be 2, this is h2, and so on. Why did I confuse you so much? I had to, because the context vector that we are trying to build for the decoder to decode into the French statements depends on every hidden state of the encoder. So take a moment back, think about the recurrence formula, think about the recurrent neural network, and how every hidden state is dependent on the context vector. Why do we need that? We need that because the context vector should be, you know, rich and very informative. It should not have just the information of the end token. It should not just have the information of the question mark. It should not just have the information of the start token. It should have a culmination of the entire input sentence, right? So hence we take h1, h2, and ht of x, that is the last hidden state, and pass it into a function called q. For the sake of simplicity, what authors also did, and it's not only simplicity, it's quite intuitive if you think about it. For the recurrence neural network that we have, h of t, it unfolds, right? The recurrence formula unfolds. So think about it. This hidden state already has information from the previous, from the previous, from the previous, and theoretically from every hidden state it has already come across, right? So this means that the last hidden state should be enough theoretically, and these air quotes are very necessary because theoretically this is said to happen, but it does not, because of a lot of things. If you have missed the RNN live lessons, we have covered it all. But yeah, you're all here. Let's talk about it again. So, due to bad gradient flow, due to tan H activation present in recurrence, most of the papers take tan H, for example. What we have is called a stop of gradient, like the gradient does not flow, and it's called gradient explosion or gradient diminution, right? It does not let the gradient flow, hence the recurrent neural network is not a good choice for sequences as we know of now. Previously it was a brilliant architecture. So coming back to our entire thing, the
Till
the key
2017.
2017. That's, yeah, that's about it. Okay, so this is a fun thing. Can you guys let us know in the chat why Ritvik said 2017? Just asking out of curiosity. And 2017 introduced something. So coming from there, the q function that we have just samples the last hidden state. The last hidden state, because the last hidden state theoretically covers the entire input sentence as well as the hidden states. So it is it is rich in information. I think we have a winner, Ritvik. Absolutely
Me
winning.
too.
Attention is all you need.
Yes.
So uh, after that, we come to another equation which should be very familiar to you all. because this is the conditional probability that Ritvik was quite vehemently uh, building an intuition upon. So what we have here is that the conditional probability of y getting along, given that all of the y's or all of the decoded tokens that are already there with t minus 1. And I think I made a mistake in the slide, and it should be y of t and not y of 1. So I am to be blamed. I'm sorry about that. Because it's a live lesson, y'all y'all probably might we won't probably have time to settle it up in the video recording. So I'm just telling it out loud that this should be probability of y of t given y of 1, y of 2 to y of t minus 1. Why do we do that? Because the current y, that is the decoded token, should depend, the current token of the decoded token should depend on every other decoded token that has already been done. So that is the conditional probability. So the conditional probability of the current token, provided that all the tokens have already been decoded, right? So that probability is quite ingeniously molded into the decoder, that is G, which again depends on C, that is the context vector, S of T, that is the current hidden state of the decoder being a recurrent neural network again, and Y of T minus 1, that is the previous decoded token. Can you guess why I'm using tokens instead of words here? I'll wait. I'll look at the chat. It's a good time to wait because there is a lot of mathematical equations, a lot of jargons coming along. So why am I using the term token instead of words when I'm asking for input sentences, target sentences, and so on?
This should be, a cakewalk for people who have already been joining us, who are regular.
Mhm.
And someone has already guessed it. I'm not
Yep,
going to say it
yep.
out loud.
That's absolutely right. So yeah, that's basically it. So what we want to drill deep down in your brains is that we don't consider words to be just the units of a sentence. We can also have subwords, we can also have characters, we can also have like the entire sentence to be a unit of a sentence. Who knows, probably some paper might use it. So what I'm trying to cover here is that we will make use of the word token or the term token more so because that is the right or the correct way of communicating with your peers who are fellow deep learning researchers. So the token is a good word. Absolutely go for it, only if you are tokenizing a word, not a subword, right? So there are a lot of concepts to tokenize and vectorize. So we use tokens just to keep it generic, keep it more generic, right? So all the tokens have been decoded and all that. And now there is this small equation. This is the last equation. I promise. I promise. This is the last equation that we want to uh, add along. Just throw it in, and by the the font size of the slides, you might know that this is the last kind of hurried equation that we tried to put in. So probability of y, that is the probability of the decoded sentences or the target sentence, is a product of every individual conditional probability. And why do we do a product? Because probability has this very cool trait or a property that if you want to have a culmination of all the probabilities and you have individual probabilities, you just product them and it gives you the right probability, right? Think about it, why it happens 0 to 1. If you multiply it, it's not going to go beyond 1, it's not going to go. Cool. So you use the product term. T goes from 1 to capital T. Capital T is the length of the decoded sentence or the target sentence. Yeah, Vijit, it's a conditional independence. That's right. That's the word or the jargon that you might look out for when you are talking about conditional probability and multiplication of conditional probabilities. So cool. Thanks
And
for.
yes, David, assuming
Yep.
independence, we do not want to assume
Absolutely.
otherwise ever.
Absolutely. Assuming independence. So that happens. And can you see that a slight c, or a small c, is also added in this probability? We want to make it a point that you all understand the decoder just does not have the previous tokens that have been decoded. It also has the context vector at each step, right? So that is how you decode at every step. Cool. So that brings us to a lot of streaming questions. So Ritvik, uh, let's go to the comments, comb them down, look out for.
Absolutely.
Yeah,
Absolutely. And if you have your questions, good time to post them here, because this is that specified interval that we were talking about where you would, post your questions to us and we would, try to answer them. I see a lot of questions, a lot of answers from your question about why 2017. And a lot of people got it right. Transformers. Congratulations. Guys, if you have any questions, we are all ears.
please
Post them
feel
in the
free to
comments.
drop in.
And that
Yeah,
was a lot of math and concepts for a couple of minutes. We are pausing here for your questions. And if you want to hit pause live through your lectures, take some notes, maybe practice a few codes, and then come back at your own pace. PyImageSearch University is for you. And the reason we say that is we never ever set deadlines or timeframes within which you should absolutely finish your course. It is up to you. It's your learning journey and your pace, and you have to find the right time for you to do those courses. But if you want to do them, and if you want to do them at your pace, then PyImageSearch University is for you. And we have over, I think, 45 courses. In fact, we are launching a new course on Monday called Computer Vision with Arduino. And this lesson, Neural Machine Translation, is actually a sneak peek into a new course, which will pave the way into another series that we were discussing about, Transformers, the hottest deep learning architecture right now. So it's just the best way to ensure yourself in a field like deep learning. And also, we had this discussion a while back, that the Transformers paper came out in 2017, and if you compare that and from that point onwards, it has always been, vision transformers, transformers this, transformer that. So it has absolutely changed the field of deep learning, and that has happened in a time frame of what, 5 years now. And if you compare that to other fields like medicine or physics or astronomy, I don't know, my man, it took a couple of 100 years for those fields to absolutely change and course correct into what they are today.
absolutely
So
agreed.
deep learning and machine learning is that field which is ever changing. There's only about an average of 20 papers coming out every day. And PyMessage University is your place to find tutorials and blog posts on them. We know that transformers and attention is the new thing. We have seen the field grow, and we see you that you're excited about it as much as we are. So yes, it's coming. And actually, this point about 21% off is exclusively for you guys. It's so that the people who are joining these live streams, who are discussing with us, throwing around their ideas and their questions, they get something back from us. So seize this moment and scan the QR codes on the screen right now. Do we have any questions, Aritra?
Yeah, I see a lot of questions coming in. So, anything about self attention? Could we get a sneak peek of self attention? I don't think self attention is something that we'll cover right now in this live stream, because it does not pave a path into transformers right at the moment. We have a lot of bunch of, uh, you know, seasonings to add on top of our live stream. We are not done yet. So we are not done yet. We have a lot of slides coming your way. So a little bit about attention, I think, not self attention though. is the positional encoding added to NMT2. So this is again a concept for transformers. I think most of our viewers right now might not know, assuming that they are not familiar with transformers, the architecture. So we'll defer this question for the time we do a transformers live lesson maybe. But yeah, to answer this question, we are not using positional encoding for NMT. I'll just not go into details of why we are not using NMT, positional encoding into this NMT, right? Okay. And they are asking for the codes, links. Yeah, I think we
I
are
think
mostly set.
I think one of the major takeaways that we are getting from here is that people are excited about transformers.
Yep.
A few things that are really important, and Arthur would discuss these as we go into transformers. It is, why is transformers such a groundbreaking topic, and we might have different answers for it. Attention, using only attention, what is attention. But the most important part of transform of seeing these topics come into the deep learning field and change them is to understand how and where we have evolved from. So you're all computer vision experts, through like along with us in PyImageSearch University, and you have seen the field of computer vision grow. So you know where it came from through classical algorithms, and you know where it is going right now through deep learning, and you know why it makes sense. But there's a very similar journey for natural language processing and transformers, going all the way into vision transformers. And for those people who want to sustain this journey for the next maybe 10, 20, 30 years, it is important to not just learn about the architectures, but learn how they are evolving and what is making them better. uh, that is just something like, it's okay to be excited about transformers, but it's also needed to understand the history of where it came from. Now over to you, Arthro. Sorry for interrupting.
No, absolutely. That we are what lies ahead. That was my entire slide deck for right what Ritik said. That is what I was coming to. It makes sense to go into transformers right after we covered NMT. But what we did at PyImageSearch is to also add two blog posts right after NMT, which are kind of like stepping stones, which is going to make the journey into transformers even better. Right now, what lies ahead, Ritvik? The first big and huge paper that we love, and I say love as in love, is neural machine translation by jointly learning to align and translate. This is also called as the Badanow's attention. Why do
Yes.
we call it as Badanow's attention? Because Dimitri Badanow is the first author of the paper, and in deep learning, it's quite prevalent to use the first author's last name and term a new algorithm that people love. So
Lynette.
this is right. So Baranow's attention. Uh, what happens to like? Let's discuss about the problems for a neural machine translation which just has recurrent neural networks, or RNNs for that matter, right? Um, what we have also covered in a live session earlier is that RNNs have a problem with long sequences. It cannot hold enough information to make the um, hidden state right at the end to be information rich. That is where attention comes in. What if I told you there is an algorithm that selects which source tokens should be attended to, so that the context vector is rich enough for a specific decoded token? All right, that's a huge sentence. I need to break it up myself. So in the input sentence, in the input sentence, or the source sentence, that is the English sentence, we have a bunch of tokens, right? Now, every token might not be useful for the first decoded French token. Why do I say that? If we go back to this, start, are you paying attention, question mark, end. And here, Feti, if my accent in French is horrible, I am so sorry to all the viewers from who are French. I'm very sorry about it, but I can't help it. So this token that gets decoded needs attention to RU, or maybe R, just R, and the question mark, right? And Wu gives attention to the token U. Attention is again coming from attention, and question mark comes from question mark. So think about each individual decoded token. Thank you, thank you, thank you for the approval. So moving on to our slide. So the term that gets decoded, or the token that gets decoded, needs to have been attended to certain specific terms in the input sequence. So Dimitri Badanov came up with this paper, and I think Ritvik has already posted the link of the archive link, and I thank him for doing that, because what I would like you all to do is, right after the stream, open this paper, download the PDF in your free time, go through this paper, because this is one of the like best papers that I have ever read. It reads brilliantly. The equations are top notch. You would understand what attention is right from the word go, right? So with that in mind, what happens actually is that the context vector needs to attend to certain parts of the input. And how does this attention work? How does the context vector get an accumulation of all the input sentences? Is deferred to a blog post, which is called Badenau's attention with TensorFlow and Keras, which is yet to be published. So this is just like the next blog post from after this series. Yeah.
So, just for the people who are wondering about what is happening right now in terms of blog posts and live streams, this is actually neural machine translation, the introduction to neural machine translation. And then we have two following blog posts, one about neural machine translation with Badanau's attention using TensorFlow and Keras, and the other with about Luong's attention. Sorry, Arithro, that you were going to speak on in a minute. And all three of them is going to provide you the foundation, or the know-how of how to translate between two languages using NMT, and using the two most foundational papers in this space, Badano and Luong's attention. So that is it, and they are all yet to be published. So this is all a sneak peek to you, PyImageSearch University members. Do not worry, you'll all get these things, the codes, the collab zips, the video lectures, everything is for you. You'll get them when they get published. And those who are not in PyImageSearch University, well, what are you waiting for? And sorry, Arthur, move ahead.
Cool. So right after that, we come to effective approaches to attention based on neural machine translation. The first author, Mintang Luong, and hence Luong's attention. Uh, Luong based the entire paper based on Badenau's attention, and made some subtle changes which are very exciting to look at. You just can't build an algorithm which speeds up another baseline algorithm. It takes time, and the subtle changes make it simpler. If you think about it, it's just out of the box. It's the same intuition, that is, it again attends to the source tokens, but just that the concept of attention is a little simpler than Badenau's attention. So don't fret. What TensorFlow and Keras,
And by
yeah,
simpler, what Arthro means is that there is a very specific switch between a mathematical operation that happens in Badanau's attention, and it's switched for something very, very intuitive. So deep learning practitioners, everything is matrices, right? Everything is metrics, and what will make it faster, or what will make it more effective than multiplication. So sorry, that was a sneak peek, but that is what is if, that is what actually happens, and that's it. And it makes the Badana's attention better through those minute changes.
Right.
So, and both of these will be covered in a future blog post. These are just sneak peeks um, for you.
Right. And also another sneak peek, because we are very generous in giving sneak peeks to everyone out here in live stream. Uh, a small sneak peek into what we will also cover while doing Badana and Luang is is an application with our model deployed to Hugging Face. And this is a space you all can go in here and use it. So this is not a state of the art neural machine translation model that has been deployed. It is just a model that you all can train right with us, along us in the blog post. So PyImageSearch students, you will get the links to the spaces, and people who are still on the fence, join us, get into the journey of neural machine translation, think about the application side of things that you might cover, and also that it gives quite good results. So
Before we
yeah.
move ahead,
Mhm.
I just want to point out two things. One is that if you have access to the spaces, uh, and if you are a French-speaking person, we are sorry, but these models have been trained on 10 epochs. Do not expect them to be as good as Google Translate. The purpose of it was to show that you can train something for 10 epochs, spend minimal amount of time on it, and you will be able to get a model that is half decent at translation. So if you have the compute, and I see there is some healthy discussion going on about AWS and compute in the comment section. So if you have the compute, then go for it, train it for a larger number of epochs, and tune the hyperparameters and beat Google Translate. But yeah, that's just one thing. Do not expect state of the art performance
Exactly.
out of the spaces, because they are not meant to serve those purposes. Sorry, Arthur.
Right. No, absolutely. And David is back again saying that Neo would approve that everything is a matrix.
Yes.
So that's hilarious. And right at the end of our slides, we have come right at the end of our slides. And what I'm going to do is also talk about the data set that we are using. So why not just wing a collab notebook right off the bat? Runtime
Arthur, can you
connect.
zoom in?
Oh, okay. Is that okay?
Yes, that's better.
Cool. So what we did here is we wget our zip, we unzip the zip, and then remove the unnecessary things that are already there. So the collab notebook is connected. I'll just wait for a while. It does not take much time. Right. So right after that is done, we can go ahead and see that fra.txt is the file, is the text file that is our data set. And once I do a head of fra.txt, it gives us what you might watch in, or what you might expect in that text file. So it's a pair of English and French terms or sentences, and also a metadata or attributions, right? So I just wanted to make you all understand what dataset we are going to use. Don't worry, we have an entire section or in our blog post covering the dataset pipeline. We also are we are huge fans of tf.data, that is tensorflow.data. We have an entire tf.data pipeline ready for digesting text files like this. So don't fret about that. What I wanted to do with this collab notebook is just to make you all understand that this is how your data might look, right? And if you do a tail of ra.txt, you will see that it's a long sentence. So it's sorted according to the length of the sentence. So right at the end, you get a long sentence.
Also, sorry for interrupting. I would
Mhm.
just like to remind everyone of our viewers to be respectful to each other. Not everyone can be in the same level of learning that we are, and it is okay because everyone is here to share their knowledge and grow. uh, Please be respectful and please try to be understanding of each other. That being said, I would not consider the context vector to be a canonical form of the input string. Formally, if you consider something to be a canonical form of something else, then you consider the operations in between them to be PCA or SVD, or eigenized eigenvector representations, and that does not happen in a deep learning architecture. You have no control whatsoever whether a PCA is happening or an SVD is happening. It is just an embedding of the data that is being passed through the encoder, and that is being distilled, or that is being put into a container, and that is your context vector, very simply put. So that being
Right.
said, I would like to remind everyone to be respectful of each other. This is a place to grow and learn, and not to put anyone down.
Grow and learn together. That is
Exactly.
the entire thing of PyImageSearch. So yeah, moving along. Right after you have fra.txt, which means that you have English to French. You might also think that we covered a lot on English to French only. Why not we cover different languages? Going to our source of data set, this is where you have a bunch of zips and essentially covering text files from different languages into English. And what we did at PyImageSearch is that we have this data pipeline set that can ingest any of the languages that you might come across. You just need to tweak a few things, because the accents in French might be different from the accents in German, I'm sorry. So you might need to tweak that, but other than that, everything is taken care of by our data loaders, so you're good to go there, right? And this is the bunch of code that I have presented inside of the collab notebook. So I think everyone kind of understands what this text file would look like. How would you get it? How would you unzip it? And how would you remove it?
And do not worry,
So
because all of this will be inside of the blog post. You don't have to
absolutely.
frantically take screenshots or take notes right now. This is all going to be provided to you.
Right. So that was about it from us. These are the spaces that we have. And Ritvik, would you want to share anything that you would like?
Absolutely. I mean, I have seen a couple of people joining in, and there have been some comments in LinkedIn and Facebook about the courses and the links. So I'm just going to paste those links again in the live chat, and while I speak about them. So this section is actually for people who are on the fence about joining. Just give me a second. So this section is, as I was saying, for those who are on the fence about joining PyImageSearch University, or they have been putting it off. Two things to consider here. One is that we are launching a computer vision with Arduino course on Monday, and that the link on the right, or the QR code on the right, will get you to the checkout page of that. It's so new that we don't yet have the
Sales page
sales
up.
page up yet. But if you do scan that one, you get PyImageSearch University full access, along with computer vision with Arduino, which is a brand new course, and you get
It goes
25%
live this
off.
Monday.
Yes, and you get 25% off on that. So that's for you guys. That's an early offer. Take it. I don't know what to say. I have tried out the course. It is brilliant. It will teach you a lot of things, and it will teach you to do, computer vision, really heavy computer vision algorithms on a really minimal hardware like
Embedded
Arduino.
system.
Exactly. And that, what can be better than that? Having a face detection system for anyone who is entering your room. For me, that's only my family members, but uh, you can have that. I mean, if you do have an alien invasion in your room, you will be able to say that, okay, an alien has invaded through computer vision. How cool is that? And on the left is PyImageSearch University, which has 21% off for everyone who is joining us today through this live lesson. It is for you guys. And a little bit about PyMessage University. So we really make it impossible to fail to master OpenCV and computer vision and deep learning. It can be to get your new job or promotion, or finish your weekend project, or launch your novel startup, or publish research maybe, or just get to know a little bit more. It's like your genius insurance to make sure you have all of the answers and working code. It will save you a massive amount of time because uh, uh, it will be a time saver where you do not need to go to five different links or go to the end of Google search to find something that will help you. You know that it's categorized inside of PyMessage University, and you will be able to find it. And yes, as new courses are being launched like this one, you will be able to find it eventually inside of PyMessage University as well.
And
And
Ritvik, I see a question from Frederick. He says that he is already a PyImageSearch University member and he has already purchased all the individual books. Does he need to buy the separate book? It's not a book, Frederick, that
it's a
we are.
course.
It's a course, Computer Vision with Arduino, and yes, you would need to purchase it because it's a separate course that we are building from ground up. So yeah, that goes live on Monday.
So the weekly blogs about on PyMessage University are on topics like these: neural machine translation, Badana's attention, Luong's attention, transformers, which is coming really soon, and they are all going to be centered around these topics, which are coming out every year, every month, and completely changing the deep learning space. So if you ever feel threatened by it, know that we have got your back. And all of this is less than 66 cents a day. I don't know what to say about that. It's less than a cup of coffee, or some other thing that you'll spend, and you'll get all of that with a 30-day guarantee, which allows you to get 100% refund within 30 days. So if you find that our code does not work or it does not solve your problem, then you get your money back within 30 days, and that's before your credit card can get billed. So what are you waiting for? And with that, I will wait for questions to come in. I do not see a lot of questions at this moment, but I will wait in case there are any more questions.
And everyone who has joined late or has missed a lot of a chunk of the introduction of this live stream, don't worry, this is recorded. It's going to get processed by YouTube just like an hour later. You come back to PyMed Search, the YouTube channel. You'll find both of us speaking about neural machine translation, making jokes about each other. So yeah.
If
uh,
and if you
yeah.
I'm sorry, but if you do have any questions around the courses, around the payment structure or anything, you feel free to shoot out a mail at ask@pymessage.com, and our customer support team will get to resolving those queries. So that's ask@pymessage.com. And I mean, do you have any queries, or is there any queries around neural machine translation, Badanow's attention, Luong's attention.
While we wait, we can also, kind of give an overview of what are the things that we covered. So the first thing that we covered is the intuition of neural machine translation. How do you see neural machine translation? How do you know that this Google Translate works? And then we covered the math or the conditional probability. How do we mold from one task to another? And then we covered the math, moved on to understanding that using RNNs is not the way to go. So we need attention. Badenau's attention, Luong's attention will come absolutely in the next blog post. So it was like a sneak peek of a sneak peek of a sneak peek. We did an inception of sneak peeks. So yeah, we just did that. Hi, Dipali. Hi, everybody. We are about to end the stream. We are waiting for people to chime on in about questions from neural machine translation. If you have got some questions, we are here. We are here for about 2 to 3 minutes. And as Ritvik has already said, if you want to ask about the pricing structure of the Arduino course or the PyImageSearch University course, and if you have further questions, please feel free to shoot out a mail at ask@pymagesearch.com, pymagesearch as it is pronounced, .com, and our customer support team will guide you through it. So thank you for your kind words. We really put in a lot of effort for our live streams. We just want everybody to grow along with us. We love to teach, as you might have guessed.
Just a moment. Just a
Yeah,
moment.
go ahead.
It is ask.me@pymagesearch.com. I am
Okay.
putting it in the chat.
Right.
If anyone wants to shoot out a mail, if anyone needs something resolved, thank you for being a member of PyImageSearch University. If you have questions around what your current pricing is and what will be included or not, shoot out a mail and it will get resolved.
Right. So again, our mishap. It was not ask@, it was ask.me@pymagesearch.com. So it's also in the chat. We'll also add the email ID at the description of YouTube. So if you guys have any problem, feel free to shoot out an email. We'll get you. And having said that, what I was covering is that we are planning to do a lot of live streams in the future. So we want all of you to be like a community around PyImageSearch and help it grow. So do not forget to leave a comment. Whatever bit you loved, whatever bit you hated, we accept all kind of feedback. Leave a like, subscribe to the channel, because we are going to make content like this freely available. That is our goal. That is our motto at PyImageSearch as well. All our blog posts are free. If you want to join the course for videos, for collab notebooks, for zips, for talking to us, having Q&As, feel free to join our courses as well. And I would say join our courses, because it's literally an insurance for everything that you go through. So yeah, thanks David, thanks Mohammed. It's really overwhelming to get positive feedback, but we also are we also have our ears open for a negative feedback, where we get to understand that we are not working as we should have. We did not use a specific term as it should have. So we are always open to feedback. I don't think we have many questions about neural machine translation. So thank you, folks. Thank you for joining in. Uh, Tolerating us would be the right word. So thank you for tolerating us. We will come back with another live stream really soon, and that's going to be exciting. Not revealing the topic, but it's going to be exciting.
Keep paying attention.
Might we?
All right. Thank you, everyone, for joining in, and we'll see you next time. Bye.